Okay, so we are told that we get minimum loudness at P and maximum loudness at Q. That tells us that what's happening at P is a disruptive interference of the two waves from S1 and S2. Whereas at point Q, position Q, what we're having is the constructive interference of the two waves from S1 and S2. So let's suppose that the amplitude of the two waves superposing at P was A and A. So what happened at P originally was A minus A, resulting in an amplitude of 0. So if we reduce the amplitude of the wave from say S2, so let's say instead of A is now reduced to 0.8A. So the resultant amplitude now is no longer 0, is 0.2A. So the amplitude at P is actually going to increase because the disruptive interference is not complete now, right? Okay, what about at Q? Q is where a constructive interference occurs. So again, let's use the same trick. Let's just assume that the two amplitudes of the two waves from S1 and S2 was A and A. So we're having a constructive interference. The resultant amplitude would have been 2A. So if we reduce the amplitude of one of the waves, we still have our constructive interference, but it doesn't result in as big an amplitude as before. So that's why the amplitude at P actually increased, but the amplitude at Q decreased.